Okay, last week we were looking at adding tangent lines. Well, now let's look at doing something with Riemann rectangles. So again, I mentioned this a little bit. There's actually a function that we can use to do Riemann rectangles. And so, think about how we would have to do Riemann rectangles without this function. We have to like go in and hand code everything and be like, put a rectangle here, then a rectangle here. It's not something that would be impossible. And maybe if you're sort of used to doing this enough, it wouldn't even be that difficult. It would just be very irritating and not nearly as robust as what Manim can offer. So that's what we're going to do in this video. So I'm going to call this, let me do the, and I'm going to call it, I think it needs to be like this. I'm going to just call it rectangles, so R-E-C-T, but capitalized. Okay, and I've already imported NumPy, but I'm just going to do it again. No, I'm not. I don't need to do that. So, okay. I'm going to do it again. So I've already imported it up here, but I'm going to import it down in this cell as well. Okay. So our class, again, the name of our class has to be that, or that has to be the name of our class. And I'm going to call it... this. And again, as always, just because I teach at Texas A&M, I'm going to set the background color to our maroon color. Okay. And now I have a function that I'm going to graph. I'm just going to make x basically go from, x is basically going to go from about, let's see, -1 to 2.5 or something like that. I only want to graph from about 0 to 2 point something. But remember, I like if I only want my x values to go from 1 point to 1 point, I like to give a little buffer to either side. So that's what I'm going to do. So xmin is going to be equal to 0. X max is going to be equal to 2 point. I've got my notes over here for what I want. 2.706, 2.706, and then I'm going to add a buffer, which is going to be equal to 0.1, and then ymin is going to be equal to 0. Y max is going to be equal to, let me see what the maximum here is. Y max is going to be equal to 2.185. And then Y buff, I will also set to be equal to 0.1 as well. Okay, and again, you'll see how the buffer gets used in the code here, but this is just to give me a little bit below or a little bit beyond, to the left and right and up and above the graph. Just because I don't want the graph to go up to the very edge of the screen. I need either the top, bottom, left, or right. Okay, so AX is going to be equal to axes. Okay, very normal thing. We've done this several times. Okay, and so X range is going to be equal to X min minus X buff to X min plus X buff. And if you're wondering why don't I just make X min equal to X min minus X buff, it's because when I draw the function is just going to go from X min to X max. Okay, whoops, this should be X max. And again, just if that's a little confusing, hopefully it'll make more sense once we see this going. So Y range is going to be Y min minus Y buff. Now I don't really have that same reason for doing Y max and Y min and Y max this way. But I just guess I want to keep things symmetric. And I'm going to say tips equals false. And then, whoops, I forgot commas here. So, by the way, if you're doing this in an IDE, I think it would probably tell you that you had made a mistake there. It would have told me if I made a mistake. And I guess there's some way you can turn that on in Jupyter here. I have sort of mixed feelings about those when you're learning, because I think when I first was learning how to program, it was Java, and I didn't even know what an IDE was, and I was doing everything in plain text. And I think it helped me learn things a little bit better because I actually had to figure out what the mistakes were by looking stuff up online and thinking through it rather than just having the IDE tell me, you know, you did something wrong here. On the other hand, it's very helpful, so I have, again, mixed feelings. But the only reason I'm talking now is because I'm just sort of rambling and I don't have a good reason to be talking. So anyways, I have a function that I've graphed. I just kind of came up with this function. I just plugged in stuff in Desmos until I got something that was roughly what I wanted. So it's going to be x minus 5 cubed plus minus x minus 5 cubed plus 2 times x minus 0.5. And remember, double asterisks means raised to the power. So this is 2 times the number, and this is the number raised to the power. And it follows standard order of operation. So it's going to raise it to the power first and then multiply by 2. Plus 1. And then my range is going to be x min to x max. So it's going to graph more, like it's only going to graph this going from x min to x max, but the grid will show a little bit more. Okay. And so now what I want to do, self.play. And I'm going to do something a little bit different. I'm going to show you another way to add, to draw. I'm going to do draw border, then fill, AX, and then self.play, create, and I'm going to call this, instead of GR, I'm going to just call it func. Okay, and I like to have, so I like to have these things kind of separate like this. So we're setting parameters here. We are kind of building an axis here. We're building a function here, and then we're adding it here. So I just like to have these gaps in the code as a way to sort of say, like, you know, now it's like paragraphs basically. Okay, so now I'm going to run this. Of course. Oh, you know what? I forgot to do. Some of y'all are probably like, you're missing it. You're missing it. You're missing the construct function. Okay, so now I think if I highlight all of this and press tab, it will work. Okay. This is always great. Include numbers, I think maybe is what it should be. Yes. Love making mistakes in front of people like this. X is not defined. Oh, okay. So I needed to do a lambda function here. So I was talking and then explaining why I was talking and shouldn't be talking. So I need to do a lambda function here. So lambda x. Okay. So again, what this means, this right here just is a function. It means take in the variable x and output that. So now when I run this, I should get something that works. Nope. Yes, so again, this is where I was talking and got, should have been axis.plot. Oh boy, okay. Sorry about that, that was kind of rough. Okay, so there we go, draw border, then fill. I should do self.wait here. Whoops. But why is the color not... Oh, that should be color there. Okay. Okay. Okay, so draw the border. So the then fill part, if I had grids going this way, it would draw it and then draw the grids, and then draw, like if I had like a grid here, it would be draw the border and then fill it. So that's what that means. Okay, so that's the function, and now what I want to do is I want to draw Riemann rectangles under that. Okay, so that's it for this video. A lot of this was just kind of another view at stuff we've already done. In the next video, we will add the Riemann rectangles.